杉原でございます。今日おはようございます。今日ですね、お忙しい中ですね、たくさんの方にお集まりいただきまして誠にありがとうございます。クラウドデイズ東京2016ということでございまして、オラクルがですね、ついこの間ですね、サンフランシスコでオープンワールドがありました。それをもってですね、日本でこれからどういうふうにやっていこうかという話をさせていただくという中で、いろいろなですね動きがございます。今日はですね、どういう話をするかといいますと、インフラストラクチャーに特化した一日となります。昨日はですね、キーノート GE デジタルのですね方がいらっしゃってですね、オラクルとのパートナーシップ、100年以上の歴史を持つ企業はですね、どういうふうにデジタルトランスフォーメーションするかというお話をいただきました。彼はですね、2020年までに GE は 70% から 75% までをもうクラウドでもう IT をやりますよという話を言い切ってましたですね。その中でやはり昨日今日できたクラウドの会社とお付き合いするよりも、メインフレームから全てのテクノロジーインフラがしっかりした、パートナーと一緒に強いパートナーシップを、作ってですね、その中で非常に重要な航空機のエンジンであるとか、そういったものを作っている中でどういうことができるかというようなお話をしていただきました。もう一つはですね、弊社のSaaSパースという話がございました。その中で最後のですね、イヤースの話をですね、我々がスティーブ・ダヒーブという人間が来てですね、どういうふうにオンプレミセスからクラウドに移行していくかというような話と、それからオラクルの三種の神器であるSaaS、パース、イヤースというこの3つですね、これを最終的にはこういった形でいろんな形でお客様にパートナー様に提供していくというお話をさせていただきました。私どもですね、もう私は就任して2年、3年になりますが、ポコとパワーオブクラウドバイオラクルと、これはこういったものをですねロゴを作ってずっとやっております。この真意というのはアジリティ、スピードですね。それからトータルコストオブオーナーシップ、もう一つは簡単に使っていただけること、そして安心安全というものを担保して、これをいかにですねお客様、社会のために貢献できるかということを標榜しているものでございます。簡単にですね、なぜ今オラクルなのかというお話をちょっとさせていただければと思います。私が言うのもなんなんですけれども、その歴史というものはコンピューターの歴史とオラクルの歴史というものがございます。これを表にまとめさせていただきました。79年にオラクルのバージョン2、これはラリー・エリスに聞きました。バージョン1っていうのは皆さんお客様あまり好かれないのでバグとかたくさんあると。だからバージョン2から始めたと。バージョン1は何かと言いますと CIA、アメリカの CIA のデータベースを構築するのがバージョン1で、それがうまくいってこれは商用的にできるなということでオラクルという会社を設立してバージョン2というのが1979年からですね、第1世代1984年はメインフレーム、第2世代はクライアントサーバーモデル、第3世代というのがグリッドコンピューティング、インターネットといったところから8i と、これはバージョン8の i、インターネットの i でございます。9i、これもインターネットの i といったところで、次に 10G というバージョン10のですねグリッドコンピューティングの G でございます。で 11G という更新をしまして、次に最終的には今ここにあるのが 12C という、この C というのはクラウドに対応できる我々データベースというものが発表させていただいたといったところでございます。今回 12C の R2 というものを発表させていただきました。それを開発している開発の責任者、この後私の後にですねアンディ・メンデスゾーンがその開発の責任者としていろいろとですねこの中身をですね話していただくと、どういうコンセプトなのか等々ですね話していただくということがございます。私ここにですね線を書きました。 よく巷でオラクルはもう後から来たとか古いとかレガシーだとか言われてますけれども、2006年にアマゾンさんが AWS というイアースを発表しております。でこれが最新で最高だから皆さんアマゾンがいいんじゃないですかというのは、日本では特にですねプレスの方がですねアマゾンと。で99年にはセールスフォース .com さんが発表なさって、これからはクラウドですと。で AWS さんも SFDC さんも素晴らしいですねコンセプトと素晴らしいチャレンジ精神と新しいフロンティアビジネスモデルを作ろうとして頑張ってらっしゃってます。でそれにインスパイアされてオラクルも我々も今まで守ってきた資産、これからも守る資産というものを例えばアマゾンさんと比べると27年の例えばメインフレームから蓄積してきたミッションクリティカルなところというのをいかにクラウドに提供していくというようなことを我々はしっかりと真摯にやっていきたいというふうに考えている次第でございます。よろしいですか。はい。こういった歴史、37年という歴史というものをやはり GE さんもおっしゃっていましたが、本当に安心して社会インフラとしてお客様のデータを守ってしっかりとしたものをクラウドとオンプレミセスでハイブリッドで提供できるかどうかというところが我々日本の社会にとっては重要なんじゃないかなと、ひいては世界のインフラにとっても重要なんじゃないかなというところが我々オラクルが他社との違いというところをですね考えているところでございます。これはですね1府13省庁47都道府県日本でございますが、ほぼ全てのところにオラクルが何らかの形でお使いいただいております。世界各国でもあらゆる世界の国家機関 NATO28 カ国中24カ国全米50中の政府世界トップの20都市がオラクルで使っていただいているといったところでございます。これはちなみに1000万というですね、これはヨーロッパ欧州とアジアにおいて使われているデータベースが動いているコンピューター、要は CPU のコア数の数字でございます。1000万コアというものを大体我々が試算しまして、今までオラクルのデータベースが動いているコンピューターのコア数が1000万コアの上で動いていると。例えば4000万コアというのはデータベースとオラクルの持っているほぼ全てのアプリケーションが動いている基盤が約4000万コアの上で動いていると。片や日本の場合はオラクルデータベース約 50% のマーケットシェアを持っておりますが、400万コアの CPU の上でオラクルのデータベースもしくは People ソフト JD エドワード EBS 等々も動いているといったところでございます。それだけのコンピューティング、イコール熱量でですね動いているといったところがこういったところで今現状がこうありますと。オラクルのクラウドといったところでは SaaS というものがございます。それからパースというものがございます。データベースミドルウェア Java もそうですしアプリケーションもそうです。ただしそれらというのは X86CPU400 万コアの上で今日本では動いていると考えてみたときに、それをわざわざコーディングして AWS に移し替えることがいいですか。それとも我々は37年間酸いも甘いもミッションクリティカルのところを37年間やってきたところのオラクルを今度は我々がチューンアップした IaaS の上に乗っけてお客様にもっとですねトータルコストを下げていただきながら SOR から SOE というような形で攻めの IT に持っていければというふうに我々は考えている次第でございます。これは実際に今あるお客様我々のオラクルのデータベース等々がですね動いているありとあらゆるさまざまなインフラストラクチャーのサーバーであるとか、私もですねここでいくつかのロゴの会社で過去働いておりまして一生懸命それをインストールさせていただきました。これがオラクルは iPhone と同じようにハードウェアとソフトウェアを融合してチューンアップしているというところではデータベースティアでありアプリケーションティアであり ビッグデータティアでありデータプロテクションというようなところでは相当チューンアップして非常に速いですねパフォーマンスでお客様に少しでも楽をしていただきながら管理ももっと簡素化してビジネスに特化したことに集中していただければというふうに日夜頑張っている次第でございます。次にオープンワールドでサンフランシスコで発表されました弊社のデーブ・ドナテリそれからラリー・エリソンもマーク・ハードも話してたと思うんですけれども、例えば一方通行でクラウドに行った時に皆さん保険はかけてらっしゃいますかというのがキーワードになってます。要するにどういうことかといいますと、やっぱりクラウドで全部コーディングリコーディングして、例えば他社さんのクラウド専業業者さんに置いたんですけれども、データは何らかの事情で元に戻すことができますかと、そこをこれからは社会基盤いろんなインフラをやっているときに考えていただければと思います。これからはどういったところで何をどんな用途で使っていくかといったところを考えたときに、オラクルの場合はなぜかといいますと、今一生懸命要するにお客様のデータセンターに入れさせていただいているもの製品をそのままクラウドに転用してオラクルがクラウドとして提供して、なおかつデータセンターお客様のデータセンターとオラクルのクラウドというのをハイブリッド型で使っていただけるように、どちらでも事情があったら元に戻せると、自前のところにデータセンターに戻せると、それが本当の意味でのクラウドに対する保険をかけてますかという提言をさせていただいています。昨日はですね、クラウドに移行していくというお話の中では3つの開発メソッドというお話をさせていただきました。すなわちオン P の今まで通りのものオラクルは提供してまいりますということと、パブリッククラウドを提供していきます。これからもですね。もう一つはお客様のファイアウォール内に弊社のクラウドマシンを置かさせていただいて、データ等々いろいろな法的な問題も解決しながらお客様にもっとアジリティのトータルコストができる削減できるというふうな手法、それからそこに行くまでに全ての皆様がクラウドにドンと行くんではなくて、インフラをしっかり見ながらどういうふうにやっていくかというようなメソドロジーをご紹介させていただきましたといったところでございます。今日この後ですね、基調講演といたしまして弊社の先ほど申しましたエグゼクティブバイスプレジデントアンディ・メンデルストーンがですね、彼がデータベースをずっと開発している責任者でございまして、彼からのお話がございます。その次にですね、弊社お客様ですね、楽天株式会社様より平井様、そして田中様、そして横内様、どういうふうなまさに膨大な重要なお客様のデータを扱っていらっしゃる楽天様にお話をしていただきます。弊社ジム・ガーガンがですね、アメリカから来まして、オラクルのコンバージドインフラストラクチャーというものはどういうものかと。ですからクラウドというものは基盤で成り立ってますので、その基盤がこれからどうかと、どういうものかというものをお話しさせていただくというふうになっております。で、最後に今日ですね、朝のテレビ番組で ZIP というのをやっているですね、博報堂の原田さんが、多分ここをお見受けするとほとんど昭和生まれの方だと思うんですけれども、若者が何を考えどういう消費をしているかというお話をしてくれるというふうに聞いております。たくさんの最先端テクノロジーを、今日 Day2 でございますが、聞いていただいて少しでもですね、役に立ったというようになればですね、幸いでございます。最後にですね、これ告知でございますが、アジア初、弊社11月18日に先ほどビデオで流れていたアメリカズカップというのが福岡で開催されますので、もしよろしければご参加いただければと思います。ご清聴ありがとうございました。本日もよろしくお願いいたします。ありがとうございます。
optimizer will now be aware of it, so future queries will be directed towards the in-memory column store without changing the application. Very easy.
One of the key benefits of using both Oracle Exadata and Oracle Big Data Appliance is the built-in integration between the two systems.
And being able to just move PDBs, pluggable databases, straight from on-prem into the cloud and back if you need to, through a couple of clicks in SQL Developer is really, really cool.
Is a compelling case for looking strongly at Oracle Public Cloud.
Okay, good morning, everybody. I'm really happy to be here in Tokyo, and we're going to talk to you about what we're doing for database as we move into this era of the cloud. And before we get into that, just wanted to mention a little bit about where we are with the Oracle database release process. Oracle Database 12c Release 1 has been in production now for several years. We have probably about 30–40% of the databases now on 12cr1. And as we move forward, the new release is Database 12c Release 2. That release is rolling out first on the cloud, and that's what we'll talk about here, and then we'll bring it on-prem soon after. It's already production and live today on a new cloud service we call Oracle Exadata Express Cloud Service. And that cloud service was launched at Open World last month. It uses our Exadata infrastructure, and it offers very low-cost entry-level database cloud service. In November, actually early November, we'll be going live on the cloud with our other two already production cloud services that run earlier releases of the database, our Enterprise Cloud Service and our Exadata Cloud Service. And then finally in December, we'll be rolling out the Exadata Cloud Machine, which is part of the new initiative that Sugihara-san mentioned for Cloud at Customer. And that'll be going production in December. And as I mentioned, we'll be shipping 12cr2 on-prem soon after that. Okay, so Sugihara-san talked about how the Oracle database has been the leading database in the industry for almost 30 years now. And the reason we've been able to do that is because we spend a lot of time trying to understand the IT computing world that the database is being used in. And as we move from one generation to the next of that world, we move from mini computers to client server to the internet, and now from the internet to cloud, we make major investments in our database technology to make sure as we go to this next generation of computing, in this case cloud, that we continue to have the best relational database technology in the industry. And we also make sure that as we move forward, that technology can be easily leveraged by our customers who can just take all these database applications they've written over the last 25 years against the Oracle database, move them to the new release, and not have to rewrite anything, but still leverage the new technologies without changing their application. Okay. So what are the key, on this slide I sort of talk about the three big areas of investment in database technology that we're working on in the 12c release and beyond. The first area I'll talk about today is in-memory database. Databases are moving to in-memory from disk-based structures, and it's an opportunity to re-architect databases to optimize them to run in this kind of environment, and we're going to be making major investments. We started this in 12c. We'll be making major investments beyond 12c. The other big area is big data. Customers are now running their businesses almost completely using information they gather from all kinds of sources. And analytics against that data is really critical to the business. And understanding your customers, if you're a consumer business, or understanding the devices you may be managing, if you're a IoT kind of business, is really core to your business. And we think big data analytics is a really critical area of investment for the database. And then finally, of course, cloud. We're doing major changes to the database architecture in 12c, including our multi-tenant architecture to optimize the database for the cloud world. So let's now go to these 3 different areas, and I'll talk about what we're doing in each one of them. So let's start with in-memory database. So this is a really major transition for database technology. And for those of you looking forward into the future, one of the key things you need to understand is that, if you're using a database that was designed 10 years ago, 20 years ago, it might be an open source database, are they going to be able to make the major investments in technology to basically re-architect the database from a world where all the data is stored on hard disks to a world where the data is now persistently in memory? It's a major change in database architecture, and we are doing major investments to deal with that. The biggest change is something called non-volatile DRAM. And NVRAM is actually about to go production probably about a year from now. And we'll see various vendors rolling that out. But once you do this, once NVRAM comes to market, all of the architectural decisions around database need to be reopened. Okay? With 12c, we've started working in this space very vigorously. We have something called the in-memory column store. The in-memory column store technology in 12c allows you to run high-performance analytics against your live transactional data, all in the same database. You don't have to move your data from transactional database to a data warehouse database to be able to get analytics. You can just do it live on the real transactional data. Lots of customers really like this capability. It gives you incredibly high performance, and it also is really easy to adopt. As I mentioned, the goal with all these innovations we do in the database is to make them transparent to your existing applications. So as you move to take advantage of in-memory database, you don't have to rewrite your applications to do that. Okay? So we came out with this technology first in 12c-01. And I would have to say the biggest request from our customers was, sometimes customers do want to run high-performance analytics in real time against their live transactional data. But some customers have certain workloads where they're very nervous about doing that. I have my business is running on this database. I don't want my analytics users running on that same database and having them potentially impact the performance of my transaction processing. So what these customers asked us for is what we are showing here in this slide. With 12c-R2, you can now have a production database running your transactions. And with Active Data Guard, you can, of course, replicate all your transactions to a standby database. And then in near real time, you can now create your column store on the standby database itself and take all those analytic users and point them at the standby. And now you've got complete isolation. You have high-performance transactions on your production database, high-performance analytics on the standby, and the analytics are against almost real-time data. It's only a couple seconds behind production. So this is something that lots and lots of customers ask for. This is new with 12c-R2. And of course, in-memory technology is all about performance. We have lots and lots of optimizations we are working on to make our query processing run faster in the new in-memory column store. This lists just a couple of the things we've done in 12c-R2, and we'll be continuing to work in this space over the next few years, continuing to improve our ability to leverage the column store to make relational joins and all kinds of complex queries run faster. One of the things in particular I wanted to call out here is that one of the new popular data types people talk about, your developers talk about, is something called JSON, which is a way of creating complex data structures in the database. JSON is now supported natively in 12c in the database. And in 12c-R2, we can now put JSON documents into our column store and do all these high-performance analytics, not only against standard relational columns, but also against these complex structures that are in JSON documents. Okay, I wanted to go through a few customer use cases who are using our 12c in-memory column store. One interesting aspect of this is 3 of these 4 customers are joint Oracle and SAP customers. You may recall SAP made a big marketing push around a database they built called HANA, which is an in-memory column store database. And they actually sold this concept really well to their customers, but their customers were like, well, why should I use HANA? I can just use Oracle database and not have to rewrite my applications or retrain my DBAs. And so 3 of these customers are basically our SAP customers using Oracle database and now using our in-memory column store. The first one's AT&T Wi-Fi. They are using our column store on top of business objects to do high-performance reporting. Villeray and Bach is using our column store actually in the SAP BW business warehouse use case and getting really high performance there. And Bosch is a big German auto parts manufacturer. They are using our column store technology with their SAP CRM applications, getting higher performance analytics. And also they were able to speed up transactions a bit as well. And then D-Mobiler is a Swiss insurance company. And they were able, again, to speed up an existing Oracle database application by using our column store. And as I mentioned earlier, one of the big changes that's about to happen, probably early in 2018, is this arrival of non-volatile memory, or NVRAM technology. We already have, actually, in our product, we've already worked out how we're going to initially support this technology in the Oracle database in the 12c timeframe. And you'll see us supporting that technology as it rolls out. The Exadata database machine technology will also incorporate NVRAM into its architecture as well in this time frame. And then beyond 12c, we have major re-architecture of the product we're working on to further leverage advances in in-memory technology, both in the database and in Exadata. And I should mention Oracle also develops a chip called the Spark chip. The Spark chip also has been optimized already with the current generation chip called the M7 for in-memory database processing, and we'll be continuing to enhance that chip moving forward as well. So Oracle is very unique in that we not only do software, we also build hardware design chips, and we're able to deliver real value to customers who use both products. Okay, so that's what we're doing around in-memory. Let's move now to big data analytics. Okay, so what's changing here? Well, the world is moving from traditional data warehousing, where customers mostly were moving transactional information from their transaction processing systems to their data warehouse and analyzing that data, to a world where now customers want to analyze more than just the transactions. You know, if I'm a retailer, I want to get information from social networks about my customers and integrate that into my data warehouse. And you know, if I'm a manufacturer, I want to get information out of my manufacturing processes and integrate that into my data warehouse. And so now the whole space of data warehousing is evolving to what people are now calling big data analytics. The analytics themselves are evolving as well, from traditional SQL-based analytics and data mining to also now include things like predictive analytics, graph analytics, et cetera. And so sort of from a pictorial standpoint, here's sort of what's going on. You know, we're starting out with our traditional data warehouses, taking our transactional data, and now there are new sources of data which can be stored in your traditional data warehouse. Oracle can store any kind of data you want, including, I mentioned earlier JSON, but also other forms of data management are often being used nowadays. There are the NoSQL databases that are good, key value store databases. They can store things like IoT data very simply. Then there's the Hadoop store. Hadoop HDFS distributed data file system is a nice low-cost way of storing large amounts of data, some of which may or may not be really useful. From the internet, things like social networks. And now customers are using all 3 platforms to do their big data analytics. And so what we call our big data management platform now is a melding of these technologies into one. And basically, we are creating what we call the big data platform, which lets you store all kinds of information and perform analytics on that information no matter where it's stored, whether it's stored in a NoSQL database, an Oracle database, or Hadoop. And the core thing we're doing here is these analytics we're providing, things like graph analytics, SQL analytics, spatial, machine learning, all these algorithms and APIs are the same regardless of where your data is stored. So you can write an application to analyze data across all these 3 data stores that are now part of our big data management platform and not have to rewrite a line of code. We work with all the popular programming frameworks out there, including R, which is becoming very popular for data scientists to use for analyzing data. And I'm just going to drill down now into a couple areas that I think are really important where we're adding a lot of value. The first one is something we call Big Data SQL. So Oracle SQL is very powerful. It's supported by all of your BI tools. And what customers have asked us for is that, if I'm now storing data across different data stores, and this data is big now. I could have petabytes of data in Hadoop and petabytes of data in Oracle Exadata data warehouse, and some data in NoSQL. Wouldn't it be great if I didn't have to take that data and try to merge it into one central data warehouse? There's so much data, it's too expensive to move it, too complicated to move. Why can't you let me run high-performance, massively parallel SQL against data sitting in all 3 places without having to move them around? And that's what Big Data SQL is all about. And we're basically using a lot of the same ideas we used in Exadata to make Exadata run really fast to make these distributed massively parallel queries run really fast across data across all these different data stores. Another aspect of this that's really nice is that since the Oracle database is sort of the controlling place you start sending these queries into, we can use all the security mechanisms in the database to control access to data, whether it's in Oracle or Hadoop or in NoSQL. And all the kind of vehicles you're used to with Oracle database, things like access control, row-based security, VPD, data redaction, all those mechanisms can now be used against data stored across your big data platform. Okay, I mentioned earlier there's a new type of data that's become very popular with developers called JSON. We have full support in the SQL language, Oracle SQL language for JSON. We give a little example of what it looks like here. And with Big Data SQL, you can now run queries against JSON data, whether the JSON data is stored in an Oracle database, a NoSQL database, Hadoop, doesn't matter, and get incredibly high performance query processing. Okay, so what about the cloud? So all these technologies I've been talking about for big data management are available now in our cloud. We've had the Exadata Cloud Service running for now over a year that can run your big data warehouses and other big workloads. We have our Big Data Cloud Service that we talk about here on the slide that can run Hadoop and Spark and other Hadoop open source technologies as well. We provide the full distribution of Cloudera up in our public cloud and in our big data appliance on-prem. And our cloud service is fully scalable. You can start small with a few nodes and then scale out to hundreds of nodes. The Big Data SQL capability I mentioned earlier is going live in a couple of months. And it will let you do this massively parallel SQL querying across data in our Exadata Cloud Service and our Big Data Cloud Service. And NoSQL service will become available also in that time frame as well. Okay. And we have a lot of customers using our technology for big data on-prem and in the cloud. I'll just call out one customer from Japan, Seven & i. They are a big user of Exadata and also our big data appliance on-prem for doing their analytics. Globally, Ambev is an interesting customer. They are a big beer distributor in Latin America, South America. And they are also using our Big Data Cloud Service in the cloud. and sending all their transactional data from on-prem systems all the way up to our cloud, and using Hadoop to do analytics against that data to better market their beer to their customers. Okay, so finally, let's close on cloud. So cloud, of course, is the big generational transformation we talked about. Oracle, as Sugihara-san mentioned, is working on three areas, three of the stack. There's the SaaS applications, PaaS, which includes mostly database, and then IaaS. We're going to focus in, of course, on database here. And strategically, one of the big values that Oracle has had over the years on-prem is that we run everywhere. Our database runs on every hardware vendor platform, on every operating system that you use, and customers really like that because it lets them rapidly move their Oracle databases to any platform where they have the best cost of ownership. As we move to the era of cloud, we're preserving that. You can take your Oracle databases and you can run them in the Oracle cloud. You can run them in the Amazon cloud. You can even run them in Microsoft's cloud if you want to. So we're preserving our portability, which we found is really valuable to customers. And I just wanted to point that out because some of the other cloud vendors, Amazon in particular, Salesforce, they would like you to build database applications using their databases that only run on their cloud. And so if you write an application against, say, Amazon Redshift database, that application runs on Amazon. It's great, but you're completely locked in. You cannot move that application anywhere else. So a lot of customers don't like that. And however, they don't really, Amazon, of course, doesn't talk about this, or Salesforce with their force.com. It's the same issue. So I think openness is something that's been really important to customers over the years, and we're preserving that moving forward. Now, why do you want to run our Oracle database in the Oracle cloud? Well, the big thing we're doing is we are optimizing our cloud for running the Oracle database. The other cloud vendors like Amazon, for example, they'll let you run the Oracle database in that cloud as long as your database application can run on a single Intel server. You're fine. With Oracle's cloud, we can run all of your workloads. And the reason we can do that is because Oracle uniquely has this family of engineered systems. And with Database Appliance, Exadata, Supercluster, Big Data Appliance, Recovery Appliance, all of these engineered systems are optimized for data management. And they are all, over time, moving up into our cloud to optimize our cloud for data management purposes. We also have commodity IaaS infrastructure that can run any application, just like Amazon. But we also have the ability to run any database workload, no matter how big, using our Exadata infrastructure on our cloud. And that makes us really unique. And I was talking to a customer yesterday, and he's like, yeah, I can use Amazon to run Oracle databases, but I can't run my big databases. So they really like the fact that we have this engineered infrastructure for the cloud. Now, what are we doing for the core database to optimize it for cloud? So the three key attributes people want on a cloud are, number one, lower cost. Number two, agility. What is agility? It's the ability to provision a database really fast. And if you're in either a production database or a test dev environment, cloning becomes really important in test dev environments. Create a copy of a database really fast as a copy of another database. Moving databases around, another example of agility. You might want to move it from one server infrastructure to another. And then scalability is another key attribute customers like about clouds. You can be a retailer, and you can be running your workloads for your customers, and then suddenly the holiday shopping season comes along. You need to scale up that infrastructure temporarily for a few months, and then when the shopping season goes back to normal, you can want to scale back down, and you want to only pay for the capacity as you use it. And so this is another key way people lower costs on clouds is by using the ability to scale up and scale down very quickly. Okay, so let's go through each of these three areas and talk about sort of what are we doing in the database to make it good at each of these attributes. So number one, lowering costs. So the big thing here is sort of capacity on demand. We will make it possible, and we have something called bursting that I'll talk about earlier, so that you can run your database steady state, then you can double the capacity on demand and just pay for that capacity while you use it, and then just move back to steady state. Okay? We have very fast provisioning, et cetera. And then for low operational costs and agility, we have a technology called multi-tenancy that I'm going to talk about that's very unique. So with database 12CR1, we introduced this new architecture called the multi-tenant architecture. And the whole goal of this is to create what we call a container database. And the container database lets you run inside it hundreds, and now in 12CR2, thousands of virtual databases that we call pluggable databases. And so the idea is that you can take what used to be hundreds of separate databases running on hundreds of servers and consolidate them down into one container database running on one server. And the key thing is management. You can manage all these databases now that you've consolidated into one container with one DBA pushing one button, and he can do a backup across the whole container. He can do recovery across the container. He can do patching across the container. And now your DBA is scaling out in clouds. They can, with a push of the button, manage thousands of databases. So this is what we call manage many as one. And this is the key requirement for clouds, where you want to be able to manage large numbers of databases at scale at very low cost. Okay. The other thing that multi-tenancy lets you do is it lets you lower hardware costs as well. Because multi-tenancy is a shared container that's shared by multiple PDBs, we actually are a much more efficient user of the hardware compute capacity, and you can run more databases on a given server with multi-tenant architecture than you can running those databases, say, in separate VMs. And finally, this is a very agile infrastructure. A pluggable database can very easily be moved around and unplugged from one container and plugged into another container. So it's a very agile environment. And in 12CR2, a couple of key things we did are really around improving agility. But let's talk first about greater consolidation density. So in 12CR1, we supported a maximum of, I think, 252 pluggable databases per container, which is probably more than enough for most of your use on-prem. But in a cloud where you potentially have millions of databases, people were asking for even higher levels of density. And so we support now up to 4,000 PDBs in a single container. That's really important for clouds, public clouds especially. We've improved things like resource management so that people running in different PDBs don't affect other people running in different PDBs by not being good users of sharing the shared memory and CPU and I/O resource. And then for isolation on a public cloud, you need to have very good isolation because two different PDBs may be run in the same container, could be run by different customers. And you need to make sure you have very strong lockdown of those PDBs to ensure there's no way you can get out of your PDB and see some other customer's data in another PDB. So we've done a lot of work in 12CR2 to improve the isolation between PDBs for public clouds. The other big area of investment in 12CR2 is around a use case for PDBs around software as a service, or SaaS. So let's say you're an application vendor or an Oracle ISV, you have a database application that runs on-prem, and you want to go to the cloud. You want to offer your software as a service on the cloud. And what you want to do there is you want to create a container database on the cloud, and then for each of your customers, you want to give them a PDB in that container. And once you're doing that, one of the things, and you could do that with 12CR1, but one of the things you can do now in 12CR2 is you can say, well, all of these customers are actually using and sharing the same code. They're running the same application, like same stored procedures. You'd like to share that across all the different customers. in the PDB, in the container database. They may have shared reference data that you might want to share. So for example, there might be data on the interest rate behavior over the last 20 years or something that all these customers are sharing in your application. You can put that data into one table, and in 12CR2 with application containers, you can share that data across all the customers in all the different PDBs in the same application container. This kind of use case also makes sense for customers on-prem. So for example, if you're Toyota and you want to deliver application service to all your dealers, each dealer could be running in a different PDB and again sharing data and metadata, stored procedures across the containers. Okay, so we talked about lowering costs using our multi-tenant architecture. What about agility? So as I mentioned, the big thing here, of course, is provisioning database really fast, making clones really fast. Test and dev environments especially benefit from agility because developers and testers love creating databases really fast, making copies of production data really fast. So for 12CR2, we really focused on this agility space, especially for test dev. So with 12CR1, you could take a PDB and create it as a copy of an existing database, but that operation required you to quiesce the source production database. With 12CR2, you can now do that online. No downtime for production while you are creating the clone. The other thing developers, especially and testers, want is once you create a clone of a production database, a few weeks later, you'll want to refresh that database to the latest version of the data in production. We call that refresh. So in 12CR2, refresh is now an online operation as well. And then finally, if you're running a cloud service, sometimes you're going to run out of room in your container, you're going to run out of resources, and you're going to want to move a PDB from one container database to another. In 12CR2, that move of the database is completely online as well. We call that PDB relocate. Okay, we have large numbers of customers all over the world using our multi-tenant architecture on-prem. And I'm going to call out just a couple of them from Japan. Before I do that, one thing worth noting is that I would say the vast majority of these customers are using multi-tenant on Exadata as a platform for creating private clouds and doing consolidation. So that's been a very interesting combination, multi-tenant plus Exadata for building out private clouds. So in Japan, Panasonic is a good example of this. They're an Exadata customer. They're now using multi-tenant on Exadata to create a private cloud. They have now about 38 pluggable databases running there. They went production, I think, about 6 months ago. Ricoh is another customer who's using the combination of Exadata with multi-tenant. Their initial PDB was around a data warehouse that they moved to Oracle from another vendor. And they're continuing to add different workloads there as well. Both Panasonic and Ricoh are here today, and they're going to be speaking later about what they're doing in a lot more detail than what I just did. Okay, the final area, so we talked about lowering costs, we talked about agility. The final big area of investment for clouds is scalability, especially elasticity. Scale up, scale down very quickly. So Oracle Database, for many years now, has had a technology called RAC, Real Application Clusters, that's very unique. Our competitors don't have this. You go to Amazon or Microsoft, they can't do this. RAC lets you scale out from not just run a database on one server, but you can now scale out to multiple servers and run your transaction processing applications or big data warehouses on multiple servers. Exadata is a very optimized platform for running RAC applications. The only thing we had to add here for our cloud is something we call bursting, and I'll talk about what that means a little later. Of course, you want to provision capacity on demand. That's a key benefit of clouds. Just pay for that peak workload when you need it. and then scale back down after you don't need it anymore and stop paying for it, right? So it's a key requirement for clouds to lower your cost of ownership. And then I'm going to talk briefly about something for massive scalability. So most of you will be able to run your business with no problem on Oracle's single server databases or rack cluster databases. But for customers who are running sort of geographically distributed workloads, and think about global payments processing system like PayPal, they have customers all over the world. It's not possible to run all their transactions on a single Oracle database. So what they want to do is have different databases servicing different regions of the world. Like shown in this example, they might have a database serving North America, another database serving Europe, another database serving Asia. And they want to route their transactions for their customers to the appropriate database. People can do this today, and they just have to do it manually. And so what we're doing in 12CR2 is for customers who need this capability that we call sharding, we are doing it declaratively for them. So they can just tell us, here's my sharding key, which is the regions of the world. When a request comes in, the application says, send this request to this given region of the world, which we call the shard key, and process it in the right region. And next what we do is we say, well, sometimes I want to ask a query about data that's across all the shards. So for example, if I'm PayPal, I might want to say, show me the sum of all the day's transactions across the world. So I want to run a SQL query that's summing up data from all the different shards. We support that as well, which is actually something that is really hard to do with manual sharding today. Okay, so this is a new capability for people at the really high extreme end of database processing. And by the way, there are customers in Japan who are doing sharding already today. I was talking yesterday to a company that does games. They use sharding, manual sharding today. They're very interested in this kind of capability. Big systems like Docomo's billing system actually does manual sharding today as well. Okay, so our Exadata cloud service is our marquee cloud service for running the biggest workloads in the cloud. So this is the key reason Oracle's cloud is very different from running an Oracle database on Amazon, for example. We have optimized infrastructure for running database using our Exadata technology. We can scale from 16 cores to huge hundreds of cores here and run your biggest data warehouses, your biggest transaction processing systems on this cloud service. On the cloud, this cloud service includes all the database options, everything with one price. It also has this capability for bursting. So if you look at this graphic on the right side of the screen, what you can see here is you can subscribe to the Exadata cloud service for, say, 16 OCPUs. And then if there's some requirement to have higher capacity for, let's say the holiday shopping season, you can double the CPUs and just start paying us for those extra CPUs, in this case 16 cores, during the shopping season. And when that's over, you can go back to your original 16 cores. Okay, so this is something really core to clouds that you should only pay for capacity on demand as you need it. Sugihara-san mentioned this earlier. We have something called Oracle Cloud at Customer. This is very unique. Amazon does not do this. Microsoft does not do this. It lets you, take all the software and the hardware we use for running our public cloud and lets you run it on-prem. And this is for customers who, for various reasons, can't use a public cloud yet. Maybe there's regulatory reasons. Maybe it's because the cloud doesn't have a data center in the right country. And so this gives you all the benefits of the public cloud, but lets you run it on-prem. And in particular for database, we are doing this for both our Exadata and our big data cloud services. So a couple months from now, we'll start shipping the Exadata cloud machine. And so what that will let you do is, Exadata today can run on-prem. A lot of you run Exadata on-prem. Exadata can be used in our Exadata cloud service on the cloud. But now you'll have this in-between opportunity to run Exadata as what we call a cloud machine. You know, it's the same Exadata software, but in addition, it's now integrated into our cloud software, and you can run that whole Oracle Cloud software as a private cloud on-prem in your data center, and still have all the benefits of the cloud business model where you pay for capacity on demand. Still have Oracle run the infrastructure for you, just like we do on our public cloud. I mentioned earlier we announced at OpenWorld a new low-end cloud service that lets you get provisioned Oracle databases at very low cost in the cloud, $175 US, cheaper than you can get a database on Amazon for equivalent capability. It uses our optimized infrastructure from Exadata to run the service, so you get really good performance, but it's not scalable. It's just for dev, test kind of use cases that we say here. And you can do some production departmental stuff as long as it can just run on basically a single core of processing power. And sort of to close out the cloud section, one of the things that's very interesting about clouds, of course, is that developers are really excited about clouds. And you need to make sure that when they develop database applications, all of the popular programming language frameworks are available. And we support all of them with the Oracle database. For the developers, we added JSON support into the database, as I mentioned earlier. REST support is also very critical for developers in the cloud. We have that natively with the database. And the last thing I wanted to mention is a tool we have called Application Express. I hear in Japan that Salesforce, Force.com is very popular for building applications. Well, the reason it's popular is it's a very nice productive environment where you don't need to be a programmer to build those applications. The problem with Force.com is those applications you built only can run on Salesforce's cloud. They can't run in any other cloud. They're not portable. Oracle has a tool similar to Force.com, except it's much better. It's called Application Express. Application Express, unlike Force.com's tool, runs everywhere Oracle database runs. You can run it on-prem, you can run it on our cloud, you can run it on Amazon's cloud. And so any applications you build with this tool will run everywhere the Oracle database runs. I know a lot of you already use that today, but as we go to the cloud, the ability for non-developers to sort of build applications out easily and intuitively with high productivity is really important. We have a great tool for doing that. Amazon, for their databases, and Microsoft, for that matter, don't have anything like Application Express. OK, so just to summarize, where are we today with our database cloud services? We have 3 cloud services. And this slide, we're just sort of positioning when you would use each of the different services. The Exadata Express service, as I mentioned, is a good entry-level service for dev, test, and for simple departmental applications, things that can run with 1 core processing power, up to 50 gigabytes of storage before compression. So pretty powerful stuff can run there. And then we have our enterprise service, which lets you scale up to about 16 cores of processing power. It runs on our commodity infrastructure on the cloud. And then finally, our Exadata Cloud service, where you can run all the workloads. You can do test, dev. You can run any kind of production workloads up to your biggest data warehouses or biggest transaction processing systems. That starts at 16 cores, and you can scale out from there to hundreds of cores. OK, so just to summarize what we talked about today, we are making big investments in Oracle database technology to make sure we continue to have the leading database as we move to this era of the cloud. 2 key areas are very independent of cloud. In-memory database technology, of course, is important for database no matter where it runs. We're making major investments there. And we will take you into the era of NVRAM and make sure the Oracle database leverages that technology from day one. We're investing heavily in big data analytics, big data management platform. The Oracle database, our NoSQL database technology, Hadoop, HDFS technologies, all integrated together to give you a very high-performing, reliable platform for doing analytics of all sorts, graph, SQL, machine learning, et cetera, all uniformly against your data, no matter where it's stored in our big data management platform. And then finally, we talked about the cloud. We talked about how our cloud is very unique in that it's open. You can run an Oracle database anywhere you want, from on-prem to our public cloud, to our cloud at customer, to Amazon's cloud, et cetera. And our cloud offering for database is very unique in that we have infrastructure optimized for database. We're moving that technology that many of you use on-prem, such as Exadata, that has optimized infrastructure engineered for database into our cloud. And we're giving you the ability to run any kind of database workload on your cloud, not just the little ones that fit on a single server. Okay, and so that's the conclusion for my talk. And what I'm going to do now is introduce our next speaker. So we have Harai-san from Rakuten coming, and he's going to be talking about some of the very exciting things they're doing for their shopping site and some of the work they're doing around Oracle Database and Exadata as well. So I'd like to bring Harai-san up on stage. Well.